Yesterday I introduced you to implicit differentiation, and with that all you did was take the derivative. However, when you took the derivative with respect to y, you had to add that dy dx afterwards. Today we're going to do the same thing, except we're going to apply it a little bit. We're going to find slope of tangent lines, equations of lines, and practice also finding the second derivative using implicit differentiation. So looking at our first problem, we have x squared plus 4y squared equals 4. It says determine the slope of the tangent line to the graph at the given point. We know by now in order to find a slope at one point, you have to find the derivative. So the derivative of x squared is 2x. Derivative of 4y squared is 8y, but since I took the derivative of a y, I'm going to add that dy dx afterwards. Derivative of 4 is 0. And you saw yesterday what we had to do is to get that dy dx by itself. Same idea today. So I'm going to subtract the 2x and then divide by the 8y. So that's going to give me dy dx is equal to negative 2x over 8y. And when I reduce, dy dx is equal to negative x over 4y. Now, just like every other time that we found a slope, we have to plug in our point. However, instead of just plugging in the x value like we're used to doing, we have to plug in the x and the y, because the implicit differentiation problem leaves us with an x and a y value. So plugging in the x and the y, it's going to be negative radical 2 over 4 times negative 1 over radical 2. That numerator is just negative radical 2. In the denominator, we have negative 4 over radical 2. You can do your keep, change, flip. So I'm going to keep the numerator, negative radical 2, and change division, multiplication, and flip the denominator. So negative radical 2 over 4. Multiply across, negative radical 2 times negative radical 2 is just a 2. 1 times 4 is 4. So 2/4 reduces to 1/2. So again, to find the slope, what we did is we took the derivative, got dy dx by itself, and plugged in our point. The next piece is the same thing. Directions are written a little differently, but it's asking us the same thing. It says find dy dx by implicit differentiation and evaluate the derivative at the given point. So the one on the left-hand side here, the derivative of y squared is 2y dy dx. And to take the derivative on the right-hand side, you have to do your favorite, the quotient rule. So quotient rule says denominator, x squared plus 4, times the derivative of the numerator, which is 2x, minus numerator, x squared minus 4, times the derivative of the denominator, 2x, all over denominator squared. I'm going to try to save some room here, so look what I'm going to do. If you have to, you can distribute it out. However, I don't have a lot of room, so I'm going to distribute and I'm going to simplify at the same time. If I look at the first piece here, 2x times x squared is 2x cubed. But in the second half of this, I have a 2x and an x squared is another 2x cubed. Subtraction in the middle, so that's going to cancel out to a 0. For the second half, 4 times 2x is 8x, and then negative 4 times 2x is negative 8x. Because of the minus in between, we have 8x minus negative 8x is a 16x. And again, if you can't see that, you can distribute it out, and you will see that you do end up just getting the 16x in the numerator. In the denominator, I still have that x squared plus 4, quantity squared. And remember, on that left-hand side, you have 2y dy dx. Just like last time, my goal is to get that dy dx by itself, so I'm going to divide by the 2y. So I'll have dy dx equals, and you can see what I have, that fraction divided by the 2y. So I'm going to do a state change flip here. 16x over x squared plus 4, quantity squared, times, and then 1 over 2y. 2 goes into 2 once, 16 8 times. So dy dx is really just equal to 8x over y times x squared plus 4 quantity squared. At this point, you can plug in your point that they gave you, which is a 2, 0. So it's going to be 8 times 2 divided by 0 times 2 squared plus 4 quantity squared. Okay, notice you get 0 in the denominator. When we get a 0 in the denominator, you know by now that that's an undefined, so we'll just leave it as undefined as our final answer there. The one on the right-hand side here is the same idea. We will have a chain rule to do with this one, though. So the first thing I'm going to do is take the derivative of the tangent. Derivative of tangent is secant squared, x plus y. And then you take the derivative of the inside. So the derivative of x is 1. The derivative of y is just a 1. However, you have to add that dy dx afterwards. Equals, and on the right-hand side, the derivative of x is a 1. And like I said a few times here, my goal is to get that dy dx by itself. Well, the way I'm going to do that here is I'm going to divide by that secant squared, x plus y. So I'll have 1 plus dy dx is equal to that fraction, 1 over secant squared x plus y. To get dy dx by itself, I'm going to subtract the 1 now. Now that I have dy dx, the second piece of this wants us to plug in the point. So when I plug in the point, which is a 0, 0, I get 1 over secant squared of 0 minus 1. Secant squared of 0 is just 1, so 1 minus 1 is 0. So again, what we did in that section was that we took the derivative, we got dy dx by itself, and then we plugged in our point. Same as the very first problem. Moving on to the next one. It says find the equation of the tangent line of the graph at the given point. Well, we've found equations before. What you do is you take the derivative. We're going to dy dx by itself. We're going to plug in our point to find the slope. With the slope and our point, we're going to plug into y equals mx plus b. Now, I should have given you a point here. I forgot to write it in your notes, so please just add this. The point that we're going to be looking at is 4, 0. So let's start with our implicit differentiation. We do have a chain rule for this first piece. Y minus 2 quantity squared. You're going to bring down the 2 first. So it's going to be 2, keep the inside, times y minus 2. That to the first power. Remember, you drop 1 on the power. And then you take the derivative of the inside. The derivative of y is dy dx. Derivative of 2 is 0, so we don't write it. On the right-hand side, you could use a chain rule, but 4 times x minus 3 is just a 4x minus 12. Just take the derivative of 4x minus 12 and you get a 4. But if you want the chain rule, you will get the same answer. Now to get dy dx by itself, let's divide by the 2 times y minus 2. So after reducing, dy dx is equal to 2 over y minus 2. Plug in our point, which in this case we actually only have to plug in our y value because the implicit differentiation is only in terms of y. So it's 2 over 0 minus 2. It's a negative 1. Remember, that's our slope. So to find the equation, which this one is asking for, we plug in the y equals mx plus b. My y value is 0, m of negative 1, x of 4 plus b. You should see that b is 4. Therefore, your equation is y equals negative x plus 4. And the last piece we have today is finding the second derivative, and you can see the notation there for second derivative, d squared y dx squared. And just like every other second derivative we found before, you have to find your first derivative, and then afterwards you find the derivative of that piece. Please pay attention to this because there will be some differences with this as opposed to other second derivatives you have seen. So let's start. Derivative of x squared is 2x, minus derivative of y squared is 2y, dy dx, equals, and the derivative of 16 is 0. To get dy dx by itself, I'm going to subtract 2x and divide by negative 2. So dy dx is equal to negative 2x over negative 2y, which is just x over y. Now that I have the first derivative, to find the second derivative again, let's just find the derivative of x over y. So d squared y dx squared equals, this is a quotient rule, so denominator times derivative of the numerator minus numerator times the derivative of the denominator all over denominator squared. So that'll be y times 1 minus x dy dx all over y squared. Y times 1 is y. Now this is where it's new. Notice in the previous problem, or in this previous line, we have dy dx. Instead of rewriting that, look what you have earlier. You know dy dx is really equal to x divided by y. So instead of having a dy dx there, you're going to call it x over y instead. All over y squared. So that's y minus x squared over y squared. And yes, I know the question you'd be asking me right now is, do I have to keep going? And the answer is yes. Finding a common denominator between 1 and y is to y. So multiply the first piece by that. So I'll have y squared minus x squared over y divided by y. Let's do a keep change flip. Y squared minus x squared over y times 1 over y squared. So we have y squared minus x squared over y cubed. Alright, and now you're going to want to tell me you're done again. However, there is one more step. Notice your numerator, y squared minus x squared. Look at your original problem, x squared minus y squared. You should see that they are very similar to each other. However, they're off by a negative. They're flipped. So instead of calling this y squared minus x squared over y cubed, I'm going to call this negative 16 over y cubed. And you should always look for that when you do your second derivatives. First, to be able to plug into dy dx like I did earlier, as well as being able to plug in your original equation somehow in order to into your last piece of the problem. Now I am going to spend the time to do the one on the right hand side here. This one will take me a little bit longer to do. You may want to go to the back because it does take some extra space. I am going to try to fit it in the space that I have left, so just bear with me here. So let me rewrite it over here. So we have y squared equals x cubed. Let's take the derivative. 2y dy dx equals 3x squared. Divide by 2y to get dy dx by itself. So dy dx is equal to 3x squared over 2y. Now to find the second derivative, it's going to be d squared y, this is just the notation for it, over dx squared. We have to do the quotient rule for this 3x squared over 2y. So denominator times the derivative of the numerator, 2y times 6x, minus numerator, 3x squared, times the derivative of the denominator, 2 dy dx, all over denominator squared, so 2y squared. 2y times 6x is 12xy, minus 3x squared times 2 dy dx is equal to 6x squared. And again, instead of having that dy dx there, I'm going to put in what it's really equal to, 3x squared over 2y. Now that's an easy denominator to square out, so I'm going to ask you to do that, and that's just a 4y squared. So in the numerator so far, we have 12xy minus, and if I distribute that 6x squared in there, it's going to be 18x to the 4th over 2y divided by 4y squared. Just like the last problem, let's put this over 1. We'll see our common denominator is that 2y. So I'm going to have 24xy squared minus 18x to the 4th all over 2y. I'm doing a keep change flip here at the same time, so I'm going to change that division or multiplication and flip the 1 over 4y, or the 4y squared to 1 over 4y squared. Numerator by multiplying by 1 stays the same. Denominator becomes 8y cubed. Now let me look to see what I have. I see at the beginning that y squared is equal to x cubed. So wherever I see a y squared, I'm going to replace it with an x cubed at this point. So it will be, let me move over. I'll move this up a little bit, I guess. 24x, instead of y squared, I'll call it x cubed, minus 18x over 8. And now for that y cubed, y squared of it is equal to x cubed, but I have an additional y. So 8x cubed y. I'm sorry, I see that over here, go back for 1 second, 18x to the 4th. I did drop my 4th, so I just need to go back and replace that. So that's really 18x to the 4th there in those two pieces. Now 24x times x cubed is 24x to the 4th minus 18x to the 4th is just 6x to the 4th. Denominator I'll leave for a second. Let's reduce. So 2 goes into 6 3 times, into 8 4 times. 3x cubes in the bottom can cancel with 3 of the x cubes, 3 of the x's in the top. So I will be left with 3x over 4y. And at this point, I can leave it just like that. Final answer, 3x over 4y. At this point, if you missed anything, you can go back and replay the video or get it from a friend. Otherwise, you can do the problems at the bottom of the page, 25, 28, 45, and 50. Any problems we have, we'll go over tomorrow.